Hi, my name is Doni Nguyen, and this is,
Priscilla Solares.
yeah, we're doing this article called Age Differences in the Precision of Memory at Short and Long Delays. So, so this is our summary. And as age differences in memory tasks is established at the short-term and long-term level, this study attempts to expand the research on how age differences vary with increasing delay between study and test. So basically, there's a lot of like established studies about short-term and long memory, but this study basically wants to see how it changes when there's a delay between the study and the test. So two experiments were conducted in which participants were asked to study a sequence of object location pairings. They then were tested to recall the precise location of the object after a variable delay.
Older participants have indicated a larger degree of error relative to younger participants at a short and long delays. Older participants do not fail to recall information at a higher rate than younger participants, but when they do recall, is less precise.
So the goal of the study was to expand the research on age differences in relation to memory tests. There are a lot of memory tests on age differences at the short-term and long-term level, but this study aims to see how the delays between study and test are in relation to age differences. There are two main goals of this experiment.
The first goal was to see how the age differences in memory for object location vary between study test delays over a few seconds to a couple of minutes. The second goal was to reveal the sources of age differences in object location recall with mixture modeling. Distinguish between responses that reflect imprecise memory for all object location from complete of recall.
My bad about that. So as for the method, the participants are two groups of people. The first group is 33 undergraduates enrolled in an introductory psychology class at the University of Missouri. The age ranging from 18 to 27 years old with a mean of 19.61 years old and a standard deviation of 1.78. They were all in good health and they were given course credit for participation.
32 older adults from surrounding area, age ranging from 65 to 80 years old, mean of 73.59 years old, standard deviation of 3.96. Good health were paid $15 for participant.
So this is where I have a problem with participants. There were 33 undergraduates from the psychology class at University of Missouri, and then 32 older adults from the surrounding area. I think that the 33 undergrads in relation to the 32 older adults was like, I would say not a good sample size because the 33, because we're looking at the age differences between younger people and older people. The younger people were all college students, and the 32 older adults from the surrounding area were just people picked from the surrounding area. And I find that if we were doing a study, I don't think it's really representative if we just choose 33 undergrads from a university and 32 older people from just around the area. I feel like the sample size is a little bit constricted due to the fact that the younger participants were all college students and the 32 older adults were just from the surrounding area.
You can start. The study took place in front of a computer screen in which the experiment was conducted. Stimuli were presented on a monitor with a resolution of 1920 x 10,000. Oh, can you restart it? I'm sorry.
I can't. You just gotta keep going. I can't. I
Oh,
literally
shoot.
can't.
Okay, participants were asked to image themselves sailing around an island and were told their belongings fell off the ship. They were then asked to remember the location of their fallen items. Images of objects were within a shining blue light. 117 distinct objects images were used. The image of the island was presented throughout the experiment, but to be used as an anchoring point.
So as for the procedure, there's two sections, a study section and a test section. So participants are asked to remember the location of an object, and then the object was shown for 4.5 seconds, followed by a half-second interval in which only the central island was shown. So the study section, basically the participants were supposed to remember where the object was, and the test section is where they apply it. So the test section, an image of a previously shown object appears in the middle of the screen. Participants had 5 seconds to relocate the object by using the mouse to click on its original location. Participants were then given 5 seconds in which they were asked to rate their level of confidence from 0, which means no memory at all, to 5, which means the best possible memory. Memory for a particular object was probed after one of 9 different lags. grouped into short, medium, and long delays. So there's going to be different intervals between the study and test section, and these intervals are going to be grouped into short, medium, and long. So this is what the study looks like, the procedure of it. That's the images right there. There's going to be a central island in the middle. Then the participants are supposed to remember where their object has dropped. And the test, they're given 5 seconds to remember where it was and click the location of the item. So as you can see right here, this is the 5 seconds. So this is the image they're shown. This is the interval. And this is when they're supposed to test. And the test means they basically just drag the object and just put it to wherever they first saw it. And then they were asked, given a confidence level of 0 to 5. This is the scale right there, 0 being no memory, 5 being best memory.
The greatest interest in this experiment was the effect of the age and its interaction with delay. There is a main effect of age with larger recall error for older participants, 129.870, 89.845, 162.169, 95% credible interval. In comparison to younger participants, 109.271, 73.489, 135.282 with a difference of negative 20.599, negative 26.887, and negative 16.357 pixels.
The magnitude of age differences was similar in the short, which is negative 16.260, negative 30.639, and negative 2.300. And medium intervals, which were negative 18.192, negative 39.968, 3.154, and increase in the long delay interval, which is negative 27.345, negative 50.775, negative 3.811. However, in the directly contrasting age differences across the different delays, there is not enough convincing evidence that the group differences at the long delay is different from that at the short or medium delay. The short being 11.085, negative 3.780, 25.568, and the medium being 9.153, negative 4.804, and 23.117. These are the results right here. The x-axis represents right here represents the recall error in pixels, and then the y-axis represents density.
This figure displays population level estimates from the linear mixed effects model expected recall error. Older participants' recall of objects' location was less precise than that of younger participants and is driven by less precise memory for the target location. There is no clear evidence of a difference in the rate of complete memory failure across the age groups. The rate of successful retrieval does not have differences in age, but the older participants' retrieval of objects is less accurate.
So as for the conclusion, the researchers found age-related decline when viewing the recall of accurate location of objects. This age differences did not increase from delays of seconds to those of minutes. Rather, the clear change in group differences with delays was after the study. Age differences were absent when probed to immediately recall object location and emerged after only 1 to 2 intervening events. Older participants appear to lose accurate spatial information faster than the short term.